Hi, Buncha.
Hi, Shahab.
Hi, Mark. Hi, Kevin.
Hi.
Hey there.
Finally, I made it.
Well, I was wondering.
Is everything okay?
Yeah, it's good. Sorry. I think last week we all were at DAC or either Lawrence Berkeley lab, but the week before I totally forgot that. I apologize.
All right. Yeah, we missed you.
Okay, since I missed the last meeting, anyone wants to update us what we are at, what the status, then we can continue.
So, Shahab, this Kevin. So I chatted with you about this at LBL a bit, but I had done a second pass going through the spreadsheet, and I ran into a couple of small, I would say, issues that I wanted to discuss with this group so that we could try to finalize. That was what I wanted to do.
Sure. Do you want to do that now?
Yeah. Let's see, entire screen. I should be sharing my screen. So this is the white paper. There. And this is the spreadsheet. Okay. So this is my version. Then I created a version, and you had said, oh, can you hear me okay?
Yeah.
I do actually. I hear you.
I can put on my headset if my microphone's not working again. There were two things I did. So I actually modified your original spreadsheet because when I copied it, it didn't have any calculations, and it can't.
Correct.
There's a bunch of divide by zeros if you don't have any data. It's kind of a circular thing. So, but first I created my version with data, and then I updated the actual original spreadsheet. And you had said in passing, I believe you said there was a couple of problems with it. So let's just go through what I have. It's pretty simple. All these are the same as before. Membership, we clarified. I wasn't quite sure I remembered. So this is a UCIE by 32.5. Okay, so there is a fee required to join organization, but I think Mark or somebody said there might not be a fee to download the spec.
No, there's no fee for downloading the spec.
So this would be, then this would be called fee free. UCIE would be called fee free, right?
Let me read the definition that we put into the text.
Free fee? Wait a minute, free fee should be fee free. Yeah, let's look at the definition. Okay, fair enough.
IP license is, this indicate whether the intellectual property associated with the interface specification is available through open source, open design, or under fee-free, no license here, or fee-based. It's gonna be fee-free or free fee, whichever is it's a correct term now.
This is where you are, okay. Yeah, it's under
Fee-free.
fee free. I think it was intended to say fee free.
Yeah.
Okay, so that answered that one. That was a simple one.
I think you had the fee or, yeah, it's correct. Sorry.
Yeah, I was unsure because I thought you had to pay to join, but not necessarily to get the spec. So I got it.
This is different, Kevin, from a spec. This is IP.
Yeah, okay. So they're not charging
For example, if I gonna come with the new modulation format over UCIe and I patent that, then that becomes basically fee-based.
right.
Or like all the school CDMA that you had to pay
Yep,
CD.
or HDMI.
Correct.
There were specs and you could download the spec, but if you built it, you had to pay a fee.
Exactly.
Okay, so this is the next one, which is 314. I was unclear. I skipped over the one that's going to take more time. So 314, that's text here, just talks about a description of number of substrate layers and line width and spacing and stuff like that. The spreadsheet is just asking number of substrate layers, and I was unclear. This is an organic package. Do I write the number of signaling layers, the number of total layers, which is 8 on top, or 828, which is the type of package?
I have a suggestion. I totally agree the text is not comprehensive. That's a good catch. Thank you, Kevin. But I think it's good if we say 828 for organic material or substrate buildup. And we keep, for example, 4, 5, 8 without basically the 2 and then balancing layers for info and silicon interposer base. For example, when we say 4,
I'm just going to make a note here. I think we'll add text, but you're saying for organic, right, 8, right, package 8 for info or user, right, it's the number of layers, right? Is that correct? What you
Yeah.
want?
I put the
We'll
note.
come back and make good language, but
Yeah.
you want to write something like that. So
Exactly.
then mine, it would say 828.
Mark,
Yeah,
you
we
have-
had to, Yeah, we had a question about that one as well, actually. So yeah, I think we should be assuming the same stack up for, that should be a fixed parameter for all the, for comparing all the technologies. I also, we wanted to potentially, while we're on this topic, add a line for what would be the minimum stack up supported by the standard. So not
Well,
necessarily guaranteeing these results, but the minimum stack up supported by the standard.
Sorry, Mark. Again, I'm gonna emphasize, I apologize for that, but we don't want to compare. We just want to mention that, hey, this IP, the minimum substrate requirement is 8 to 8.
Yep, this IP, which has 64 lanes, so it's four high stack. Oh no, this is UCIe, sorry. But it's still 64 lanes. It's it's a checkerboard quadrant of receivers and 16 receivers and transmitters. It has to have an 828.
Exactly.
A 16 module could have a 424, but that's a different PHY.
It would be different data entry point.
And then I would enter different numbers of lanes and stuff.
Exactly.
So
Right, but this would be more informative if if we have the most number of parameters the same between the standards that we're comparing.
Can you elaborate more?
Well, many of these standards, and I mean bunch of wires in particular, I think it's both a blessing and a curse for bunch of wires, in that it can be configured in the same way as UCIe, for example, but it doesn't have to be, right? So we can do a bunch of wires on a really, really small stack up, for example, and obviously not with the same performance, right? But I mean, if we were to describe, or if we were to describe something that was, let's say in a corner of the solution space, right? That wouldn't be as helpful for the document as something that is, very close to the same mark in the solution space that UCIe stands in.
I
what I'm
think the
saying?
reason I'm confused is, so let's pick two examples. A single bow slice, which is 16 data lanes and a clock, right? That can
Right.
fit in a 222 package,
It can.
and it has 16 data lanes only,
Yeah.
either receivers or transmitters. If you a 4 high stack of that takes an 828 package. Both of those are physical. They're different instantiations of PHYs, right? They're different
Okay.
files. For a given GDS file, I'm not talking about for a spec, but for a given GDS file, if it's a by 32 UCIe module or a 4 slice high, stack of bow, then they both need an 828. If it's a single stack of bow, it needs a 222, or 2 stacks is a 424, which is the same as a by 16. Those are all possible answers, but if you in the top right here, you write in one of those 5 things I just listed, the data all below it flows from that one thing. If we're going to talk about a single slice of bow, then it would only have 16 data lanes and 16 data wires and 2 clocks or whatever, but it wouldn't, it would, yeah, it would not be you can't be both a 222 and a 828 for a given PHY, I don't think.
And if you can support a 222, because this is the minimum number of layers, you should list it as a 222 instead of 828.
Yeah, you should. I guess this brings up a different question, which I need to think about, but all of these unit bandwidth stuffs are in each direction. So how would you handle a single bow slice? What is the two bow slices will have some bandwidth X, and a single bow slice will have the same bandwidth really, but it's only in one direction. It's not full duplex. And I haven't really thought about that. That's gonna be weird.
We can get back to that one, but first I don't want to ignore Mark's
Okay, I'm
comment.
sorry.
Mark, are you okay with it? Did you get the point?
Yeah, so I think, well, so what was suggested over here on the Blue Cheetah side was that there should be a set of parameters that are self-consistent, right, for each column. Right, so in this case, like for what Kevin described here, right, the number of substrate layers does have to be 828, right? And we should try to match as many of the same conditions for each of the columns, right? So a bow column would also have 828. What?
No. If your bow can do 626, it's your IP.
True.
Just write it 626. It's been more beneficial for people. Just write
Okay,
424 if this is a good selling point.
but that's not what I'm saying here, right? So there's a set of conditions, right, which a particular result is valid, right? We all have IP that's configurable in different ways, right? And so they have many of these things have a very large configuration space, right? In my past life, I worked with an IP that had more possible configurations than there were atoms in the universe. Okay. So I'm familiar with this problem of configurability. And so when you're comparing things, even if it's not supposed to be, a sales sheet, right? It's an informative thing that we're trying to do here.
So,
And if you're trying to be informative and, draw a comparison between two things, it's beneficial to the comparison to fix as many of the variables in the solution space as you can, right? So in this spreadsheet, of course, Kevin's conveniently made a UCIe by 32, right? We would do the same thing for bow, right, to make it a by 32, right? And certain other parameters. If there was a range of voltages possible, we should try and match voltages. If there's a different amounts of reach possible, we should match reaches, things like that. The idea being to give people an idea of, a point in the solution space, and then the thing that they're comparing against is, is it UCIe or bow or can-do bus or something else?
I think the problem is that if I understand correctly, is you're trying to use this Excel sheet basically for a comparison purposes. The first goal right now is not to compare. If you can do 828 and if also you can do 424, have two sets of entry in this Excel sheet.
Yes, that's exactly what I'm saying. So for a certain set of parameters, let's see, and then how does the area work out? How does the power consumption work out for that set of parameters, and keep the set of parameters as consistent as possible. But then also in additional rows to be able to explain the ranges, right? So this standard is, capable of a 2-2-2 stack up under some condition, which is not the same conditions that we have in the rest of the table, but it is within the range of the parameter. Does that make sense?
It does if we want to use this Excel sheet for comparison. If not, this is the way that we are suggesting people to report. And we believe this is minimum information that you guys need to report when you're sending it to your customer.
Yeah.
For example, you want to say that you have a PHY, and then you put 828 here. I'm just picking up an example. And you make a note, hey, I do have another one, which is going to be 424, but half of this density. For example, that
Right.
maximum stackable unit is not going to be 1, for example. It could be in case
yeah,
of
that's what I was thinking. If we had a single slice, the max stack units would be 4. Each
Exactly.
slice would be, would take 2 signal layers, but the area and power and all that would be representative of a single slice, and the max bandwidth would be representative of a single slice, I guess, and the calculations accordingly.
Last time we did area and everything based on a slice, but we reported all those numbers based on the maximum number of allowable stack.
Yeah, okay. That makes sense because, and that's kind of where I was getting confused on all these is all the amortized physical area stuff.
Mhm.
But anyways, back to this. So yeah, this one is like Mark said, a little bit simplistic because UCIE is so prescriptive that this particular PHY only has one max stack units. It only has one unit size, and that's it.
Mhm.
It's definitely, there's one unit size, there's a fixed area and all that, and there's a fixed substrate layer. So it was pretty easy. It's harder with a BOFI. So
No, for Bo is gonna be the same, except that max stack is gonna be 4. And when you say 4, then for sure you need 8 to 8.
okay, but with the 4, you need 8 to 8. With only one bow slice, you need 4 2 2 2 or something, right?
Yeah,
So
but usually
depends on
people
what edge
report
density. Okay, so it says 4 reported edge density. I see.
Yeah. And this is what I'm saying. We need to have, because if we go down to the further rows below, right, the pink rows, that are measuring things like, you know, terabits per second per millimeter and picojoules per bit and milliwatts and things like that. All of those results are valid only for a single configuration
Right.
further up in the table, right? If you change something further up in the table, then things in the pink rows might change also.
correct.
So the way that I'm looking at this is, you know, the table represents, you know, a particular configuration point, and we agree that for UCIE there's not many available configuration points, right? But it represents a configuration point for which the, you know, the pink rows are the result. And what I'm saying, you know, the Blue Cheetah approach to answering this is to pick a solution space, you know, as similar as possible to the UCIE one that Kevin started, such that, you know, the pink rows are a reasonable comparison between the two standards. What I'm then, so that's, you know, I'll draw a line under that, and then say, and additionally, what we would also like to see in there is a few rows describing the possible ranges of some of these answers, which would lead to different results in the pink rows, but we're not actually going to calculate it out for a million different possible combinations. Does that make sense?
I'm kind of losing. I think an example is going to be, are you working on an example? You know, if you were going to copy the spreadsheet and
Yeah.
mark it up. So if you've added some rows there, it'd probably be, rather than talk about hypothetical,
Okay.
show me specifics would
Okay.
probably.
So let's do that. Let's why don't you finish, Kevin, and then I'll talk about the additional rows that we'd like to add.
You okay with that, Shab?
Yeah, for sure.
So I had hardwired all these equations. I think you were saying one of them was wrong, but if you remember that, it would be.
Let me review those equations one more
Okay.
time because
All right. So where I got confused before was just about the fact that everything's unit in one direction. So normally UCIE reports would say there's, you know, 2048 gigabits per second out of this PHY, but this is per direction. And so then the
yeah, the reason that we picked per direction because there were some phi those days that they were not symmetric. At least they had that option to not making them symmetric.
yeah.
And for example, for XSR, LR, it's so difficult to not have basically report TX and RX together. We had the problem there too. Then we decided divide by 2 area. But now I think we have a better understanding. We can formulate.
All right. Well, anyways, you can just look at the equations and see what's divided by what and for each of these, and hopefully they make sense. So then these whole metrics I've never understood.
Mhm.
So I just said I'm not clear. And honestly, I think James wrote this. Why? What are we trying to, so this is total RX plus TS plus clocking amortized. What does that mean?
It means sometimes your clocking is shared between different number of channels.
Sure.
This
So
is a
in a bunch
single
of wires in
TX.
UCIe, there's one clock pair for 16 TX or 16 RX.
Exactly.
Oh, right.
Then you basically do the entire TX and RX and clocking area, and then you divide it by 16. And that area will be X and Y, reported X and Y for TX and RX. I think the problem that you get confused is that we used to report this as an area. Now we are saying X dimension and Y dimension.
Yeah,
Why?
so so what was this 3.4? Maybe we should look at the text. No, that's not 3.9. I'm sorry, I apologize. This is exclude clocking.
Yeah, exclude clocking is that you don't amortize. This is for 42, 43.
I think these numbers are swapped then. So 3.9 is exclude clocking and no, they both say exclude clocking.
Okay, then that's the good catch. I think, James, you need to review this one more time.
So this one probably means
Um,
include clocking. At least from the table, it looks like include clocking is first and then exclude clocking is second.
Correct.
But I mean, if your clock is in the middle, if they're all if all your slices are the same size, it's probably not too difficult to do this. I don't know. And maybe if there were an example, it'd be a little easier to figure out.
I'm getting to your point. Maybe this is if you want to make it easy, is to just ignore all 40 to 43 and just call total area of the slice and then report how many channel it is. We do have it divided by number of channels. Then we can ignore, exclude, include, blah, blah,
Okay, so
blah.
we have the dimensions and we have the total number of, is it data lanes, right? That we would use. Because if there's 64 wires, but you care about channels, so data lanes. So you
Yeah.
divide by that by E23, which is the same we use for this. I think you divide, yeah, it's E23.
But
So
let's think about it because we have only 1 minute. We better not to decide. Line 40 to 44, also 45. We wanted to be more specific and extract more information. I think during the review also we said, okay, we will ask, maybe people not provide. But if you think it's too complicated for this round,
So I am not saying that. I'm saying I don't understand it. So, you know, maybe like you said, James wrote it, you understand it because you know the history of where this came from. I was just trying to fill this out as a user. I think I've got through everything now except this. We need a little bit of brush up on this text. And I think we're in pretty good shape. But I need one of you experts to show me what this is supposed to mean. Maybe we
okay.
can do that in the next meeting.
One recommended question, Mark, were you okay with this 40 to 44 or you haven't reached there yet? As a second example, if both of you have problem, then it's a major.
we can could
So-
plot in the table. That's why I wrote that way. I'm kind of following from the spreadsheet. I think I saw. Yeah, I think
Yeah,
that's
that's
probably
separate,
the
James.
size.
Let's see if it's only Kevin's problem or Mark also had the same problem too.
Yeah, so
If both
so
of
we
them
also
have
weren't-
problem, then something we need to do for sure.
yeah, so we also weren't able to fill in those rows.
Okay, then let me prepare something for next week. I will explain what does it mean, and also I will suggest to simplify it. Then we can pick. How's that?
Sounds good.
Yeah.
And all this stuff I showed is in the same directory. So these are live files that you all can find if you want to
Okay.
look. All right. I'm going to stop sharing.
Thank
So
you
was
very
it-
much.
Thank you, guys.
All right.
A
Thank
quick
you.
question,
Bye.
if I could.
But
Yeah.
The rows, so those rows, was the intent there to try to create a I don't know what we want to call it, but a unit benchmark for the area? Is that the idea?
I'm not sure.
I mean, to me, if we start with where we were, Anu and Kevin Yee and people who are buying IP, we want to make sure that when stuff's reported, that we know what latency means, we know what power means. I don't understand why these unit amortized areas, they don't make any difference to an end user, to me. I don't know. I think total area.
Not for
makes
die to
sense.
die, but for different PHY it may.
Okay.
Because for example, if you need every 2 channels, you need to basically put 1 clock. Then people just report used to report just TX and RX, not clocking. And then they were saying, oh, for every 2 channels, you need a separate clock too. Then the area was totally large. That's why we said, okay, how about if you say how much is the clock area? But I will simplify.
Okay,
That's-
it's good.
that's-
Good question, Mark. Thanks.
Thank
All
you.
right.
Let you all go. Thank you.
Thanks.
Thank you. Bye-bye.